Welcome back, everybody. Today we're going to be talking about Gauss sums. So Gauss was a mathematician who lived about 300 years ago, and when he was in elementary school, he wasn't listening in class, and his teacher decided to punish him. So she was basically like, Gauss, you're in timeout, until, of course, you can solve the problem that I'm about to give you. And the problem she gave him was to add all the numbers from 1 to 100 up. So Gauss, instead of going to the corner and maybe spending an hour adding all the numbers up one at a time, he almost immediately gave his answer to his teacher, 5,050, which after his teacher did the calculations themselves, was indeed correct. So how did Gauss do this so quickly? Well, that's what we're here to find out today. So let's start off with a simple example. So, let's say we had to add this sequence of numbers up together. Let's say the numbers were 1, plus 2, plus 3, plus 4, plus 5, plus 6. Alright, so we all know how to do this. Just adding one number at a time. 1 plus 2 is 3, 3 plus 3 is 6, 6 plus 4 is 10, 10 plus 5 is 15, 15 plus 6 is equal to 21. Now, here's the way that Gauss approached his problem. Instead of adding the numbers 1 plus 2 plus 3 plus 4 plus 5 plus 6, he added the two numbers at the end, and then he added the next two numbers from alternating sides, and then he added the middle numbers, right? So, okay, let's just see what happens if we do that. Okay, if we add 1 plus 6, we're going to get 7. If we add 2 plus 5, we're going to get 7 again. And when we add 3 plus 4, once more, it is 7. So clearly there's something of a pattern here with all the repeated 7s. Okay, so now let's go over the formula that Gauss later in his life came up with for adding this kind of sequence. So I'm just gonna write this as the variables that we can easily use. So the sum of this type of sequence of numbers is going to be equivalent to this. So what are these variables up here? Well, A is the first number of the sequence. So let's say in our example here, that number would be 1. Z is the last number of the sequence. So in this case, it is 6. N is the number of numbers that we are going to be adding. So in this case, we're adding 6 numbers together. So that N in this case is going to be equal to 6. So let's just try this formula out. Let's substitute in all these numbers that we have in our previous example. Okay, so A is equal to 1, Z is equal to 6, and N is equal to 6. So 1 plus 6 in the parentheses multiplied by 6 divided by 2. Now this should give us the answer that we previously got here. This should give us 21. Alright, so what does this give us? So 1 plus 6 is equal to 7. 7 times 6 is 42, and 42 divided by 2 is indeed 21. Cool, right? Alright, so this is basically the formula for Gauss's sums. But why does this work? Why exactly does this work? Well, it turns out when you're adding an arithmetic sequence of numbers with a common difference, meaning that every number that increases in this sequence, so you're adding 1 plus 2, that's a difference of 1, right? 2 plus 3, that's another difference of 1. As long as this difference is constant, this formula will always apply. And in this type of sequence, when you're pairing numbers up corresponding to in this manner, you're going to get that this sum between 1 and 6 is going to be the same as between 2 and 5, which is going to be the same as between 3 and 4. This is always going to be true. There's this constant sum between the first and last numbers, before the second and second to last numbers, the third and the third to last numbers. And no matter how long the sequence is, this sum will always be constant for the given sequence. Now, where does the n divided by 2 come from? So, since you're pairing these numbers up, you can logically deduct that if you have n numbers and each pair has 2 of them, you're going to have n divided by 2 pairs. In other words, if you're making n divided by 2 pairs of numbers and each pair has 2 numbers, in total there's going to be n numbers. So if you each pair sums to this constant sum, and this is the number of pairs, and divided by 2 pairs, the product between the number of pairs and the sum of each pair, which is constant, is going to be equal to total quantity of the sum. So let's try this out with Gauss's problem. So Gauss was asked to add all the numbers from 1 to 100 up together. So, okay, obviously we're not going to be writing every single number out. So let's just write a couple. So 1 plus 2 plus 3, and then we will just skip the middle ones, and he's adding all the way up to 100. So our formula, if we recall, is a plus z times n divided by 2. Now, because this formula is the way that it's written, we only really need to know the number of numbers we're adding, the first number, and the last number. So do we know the number of numbers we're adding? Well, every single time we add a number, that number is incrementing by 1. And the last number is 100. So there's going to be a total of 100 numbers that we're adding. So in this case, n is equal to 100. The first number we're adding, clearly, is 1. The second number, the last number, is 100. If we substitute everything in, let's see what we get. 1 plus 100. This quantity multiplied by 100 divided by 2. What does this give us? Well, on the top we have 101 times 100 divided by 2, which is equal to 101 times 50, which is equal to 5,050. And if you use a calculator here, you're going to find that you get the same answer. If you just add every single number up together, you're going to get 5,050. So this is essentially a really quick way and precise way to add a series of numbers together. Now, let's see if we can apply this to a situation where maybe the common difference is not 1. Rather, maybe it's 3 or 4. So let's see if we can do that. Alrighty, so let's do this sequence. 2 plus 6 plus 10 plus 14 plus 18 plus 22. So in this case, we're not incrementing by 1 anymore. We're incrementing by 4, right? 6 is 4 greater than 2, 10 is 4 greater than 6, and so onwards. So this formula will still work as long as, if you heard me correctly the first time, we add a common difference between each of these numbers that we're adding. So the formula is a plus z quantity times n divided by 2. In this case, we have a is equal to 2, z is equal to 22, and n is equal to 6. 1, 2, 3, 4, 5, 6. Okay, now let's see what we get with this formula. We'll have 2 plus 22 times 6 divided by 2. What is this going to be equal to? It's going to be equal to 24 times 6 divided by 2, and that is 24 times 3, which is 72. Okay then. Now, is this what we get if we add all these numbers together? Well, let's see. 2 plus 6, what is that? That's 8. Alright, 10 plus 14, 24. 18 plus 22, 40. 40 plus 24, that's going to give us 64. And when we add 8 to it, that is indeed 72. So clearly, this method works for common differences not equal to 1. However, if the common difference is not constant, there is no common difference, and the numbers increment in whether it be another maybe geometric sequence, but it could also just be a random sequence. If it went 2, 5, 10, 17, -3, these differences are not constant between every two numbers, so this formula would no longer work. And now, that's not to say that a formula perhaps does not exist for this sequence, but it probably would be extremely complicated and not easy to use. So that was Gauss's sums. It's basically an efficient and precise and quick way to add up an arithmetic sequence with a common difference. I hope you enjoyed, and I'll see you in the next video.